So we're going to start out just reviewing some basic kind of concepts about triangles that we should understand. I know we know the basic, right? What's something you know about triangles? They have three sides. Thank you, Osford. Give me a thumbs up if you knew that. Triangles have three sides. Perfect. Hopefully all of us, right? Anything else we know about triangles? That's all we know about triangles?
Triangle.
What?
Triangle. They're a triangle.
They're a triangle. Yeah, there's different types of triangles. What are some different types of triangles? Obtuse. Good. What other types of triangles? Scalene. That's a good one. Good pull. Right triangle. Nice. What does a right triangle have that other triangles don't?
Nice square.
A little square in the bottom, which tells me that this is a 90-degree angle, right? So what we're going to be looking at today is just right triangles. It's the only type of triangle. We're going to narrow in our focus here on just right triangles, okay? So just some beginning stuff out of the way. We all know triangles have three sides, but what we may not know is that the longest of those sides, the longest side of a triangle is called a hypotenuse. Has anybody ever heard that term in math before, hypotenuse? Yeah, maybe, maybe not. Everybody go ahead and say it, hypotenuse. Okay, it sounds like hippopotamus, but it's the longest side of a triangle. Hypotenuse. The other two sides, the not longest sides of a triangle, the other two sides are called the legs. Everybody say legs. Thank you. Yeah, way easier to say than hypotenuse, but those are my three sides. I have one hypotenuse and two legs. Now, just because the hypotenuse is the longest side, this piece of information is also always true. The hypotenuse can't be longer than the combined length of both legs. We'll take a look at what that looks like and what that means in a second, but just in general, that has to be true for us to have an actual triangle. So let's take a look at triangle ABC here. Here's triangle ABC. Angle A all the way up here, angle B down on the bottom left, and then angle C in that bottom right. Okay? And then I have my side lengths. A, which is 3 units long, B, which is 4 units long, and C, which is 5 units long. Okay? Which of those three sides would be the hypotenuse? A, B, or C? C. What makes you say C? It's the longest side. It's the biggest number, right? 5 units. I'm going to do that in pink. That is my hypotenuse. What two sides are my legs of this triangle then? If C is my hypotenuse, what are my legs? A and B, which are 3 and 4 units long. Yeah, Sophie? I think, yeah. Okay, Gianni was going to go, and then you can go after that. Go ahead. So, triangle ABC is a right triangle. We've got one 90-degree angle. That's angle C, like we said. And what I mentioned in the warm-up is the right angle of a right triangle is always across the hypotenuse and pointing at it. If I have a 90-degree angle in a triangle, that's the biggest angle I could have in a triangle, or in a right triangle. So the biggest side is always going to be across from the biggest angle. So in this little box here, I want you to make a little pink arrow, because like I said, that arrow is pointing directly at the hypotenuse. This is extremely important that we know which side is the hypotenuse, because when we see the equation that we're going to be using today, the hypotenuse is kind of off on its own. The legs, it doesn't really matter which one is A, which one is B, but it really matters which side is side C. All right, like I said, the right angle opens up to both ends of the hypotenuse. It's like these two little yellow lines are my legs, right? The line connecting the 2 feet would be the hypotenuse. Like I said, the largest angle always opens up to the longest side. In a right triangle, the right angle is always the largest angle, so therefore it always opens up to the largest side. Right, if I have this angle here, that's going to be across from my longest side. When I'm looking at a triangle, you'll notice that I've got I've got ABC and I've got ABC. So let's look at A for a second. What's the difference between these two A's that you see right away? This A right here and this A right there. One's capital, right? Anytime I have a capital letter, I'm talking about an angle. If I have a lowercase letter, I'm talking about a side length. So side C is 5 units long, but angle C is 90 degrees. Does that kind of make sense?
No. Yeah.
No? What about it doesn't make sense? If I have side C, angle C is pointing to side C, angle A is pointing to side A, angle B is pointing to side B. Right? So the uppercase represents the angle measure, but the lowercase represents the distance of that side of the triangle. All right? Angle A always opens up to side A, blah, blah, blah. Okay, any questions about any of that? That's just all background information. That's not really the lesson, but it is something important that we should note, especially this part here. My legs have to both be shorter than my hypotenuse, but my hypotenuse has got to be smaller than both the legs combined. If I add those legs together, they'll definitely be more than my longest side. Anyway, this is what we're actually going to be kind of learning and doing. Once you get it, go ahead and glue it in. Yellow?
Yeah.
Okay. All right, so this formula that we're going to be introducing today is called the Pythagorean Theorem. Everybody say Pythagorean Theorem. Try that out. Yeah. Sometimes it's called the Pythagorean Theorem, Pythagorean Theorem. Doesn't really matter. Either one works. Now, this is like the most heavily referenced mathematical formula in TV, movies, all kinds of stuff. So once you hear about this and we learn about it, the more like movies and TV and stuff you watch, the more this is going to come up, and you're going to be like, oh, hey, I actually know what that is. So this is definitely going to come up in years and years down the road in your math classes. This is going to be our first introduction to it. It's pretty straightforward. It's pretty easy. as long as we're plugging in A, B, and C correctly. You'll notice that I highlighted A and B in yellow and C in pink. Which sides of my triangles might A and B represent? What do we call those again? The legs. What about C? What's that one called? It's a little bit... Let's look back. What is it called? The hypotenuse. Okay? So, to use this formula... Wait. To use this formula to find the unknown length of a hypotenuse, like we just said, we're going to do three things that sound very familiar, hopefully. We're going to square the legs, we're going to add them, and then we're going to take the square root. We're going to square them, we're going to add them, we're going to take the square root. Does that sound familiar at all? Yeah, when did we learn how to do that? Friday, this morning, when we were going over the warm-up. Those are the same three steps that we saw on this graph. Square them, add them, take the square root. So let's use triangle ABC from this previous note sheet here. Okay, A is 3, B is 4, and then let's see if we can figure out what C is. A is 3, B is 4. So for A squared, I'm going to plug in 3. For B squared, I'm going to plug in 4. And then we're going to try and see if we can find what C is equal to. We already know it. Yeah, go ahead. We already know what C is equal to. But we're going to test this theorem out and see if it works out for us. Okay? Go ahead and change that. I don't know why it says all three. It should say square both numbers. That's my bad. What is 3 squared? Let's square it. 3 squared gives me 9. What about 4 squared?
16.
16. Then I'm going to add them together. What is 9 plus 16? 25. So now I have 25 equals C squared. The only thing left to do if I want to find C is just take the square root of both sides. If I square root the left, square root the right, what is the square root of 25? That's just 5, right? So I get side length C is equal to 5. Again, if I look back at my diagram, is that how long side length C was? Yeah. So this formula only works for right triangles, but it works for every single right triangle that we're going to see.
Can't we just put the side and not have to show the word?
What do you mean? Oh, I see what you mean. You're not going to know what C is.
Oh.
Yeah, I'm just using this diagram to test it out. Yeah, no, don't worry. Like, look at this example right here, right? What is side length A equal to? Let's highlight my legs. Well, how do I know which sides are my legs? How do I know which side is my hypotenuse? Did we talk about it? It's the largest, right? So I have 5 and I have 12. This is definitely not the hypotenuse. But I don't know what side length this is. So I can't definitively say that's the longest side, right? Because I don't know. Where else can we look to figure? What's that? It could be bigger than 12. It probably is. But is there like a little symbol inside this triangle I told you to look at maybe to find the hypotenuse? The little square, right? Let's look at this little square. If I turn that right angle square into an arrow, that arrow is always pointing directly to the hypotenuse. Even though I don't know how long it is, if it's the side that's across that 90-degree angle, it has to be the longest side of the triangle. It's all proportional. The largest angle points to the longest side. The smallest angle to the smallest side, middle angle to the middle side. So I'm going to call this side here C. Since I don't know what it is, I'm going to give it a letter. Those must be my legs down there. So I'm going to use the formula a squared plus b squared equals c squared, where a and b are my legs and c is my hypotenuse. What are the two lengths of my legs here in this diagram? There's two lengths of the triangle that I know, right? They're both legs. What are those two lengths? 12 and 5. I'm going to plug those in. I'm going to square them. What is 12 squared? 144. What is 5 squared? 25. Okay, so I squared them. Now I'm going to add them. What is 144 plus 25? 169. Now I have 169 equals c squared. Now this actually reminds me of a lesson that we did prior. Where is it at? These ones right here. Look at these equations. X squared equals 144. We took the square root of both sides. We got x equals 12. B squared equals 100. Took the square root of both sides. B equals 10. You guys see that? Now we're just doing the exact same thing. Where is it? If c squared equals 169, I need to take the square root of both sides. Right? The square root of 169 is 13 times 13. Is there any pairs I can bring out of that square root? Yeah, pair of 13s. So what is my side length C equal to? 13 units. We want to throw units on there because it is a measurement, it's a length. Some of the problems might give you like centimeters, inches, feet. Let me see. Not on this worksheet, but in the future they might. So we'll just put units on there for now. And that's how we find the missing hypotenuse. Now I know that this side length C is equal to 13. Does that make C the longest of these three sides? Yeah, between 5, 12, and 13, what's the largest number? 13. So that is the longest side. But remember, in a triangle like this, the legs, when combined, have to be greater than that longest side. What would I get if I combine these legs together? What is 12 plus 5? 17. Is that bigger than the hypotenuse? Yeah, so that works out. You don't have to think about that necessarily. It's just something to have in your mind. This is the work that we're going to be doing today, okay? What questions can I answer about that? Quick show thumbs, how we feel? Up, great. Sideways, okay-ish. Down, bad? Okay. I really appreciate those of you that are with me. I know it's Monday. I know we're struggling to get into a swing of things, but this is